let's talk about and do some problems where we have to rationalize the denominator. Once again, the reason why we have to rationalize the denominator is because we cannot leave a radical in the denominator of our answer. So for instance, in a minute, we're going to go through how to rationalize this denominator. The problem is, you notice we have a square root of x in the denominator. In the math world, they do not want us to leave a radical in the denominator of our answer. So we have to get rid of that radical. Now just before we start this, I'm going to actually do 3 problems. Let me go ahead and write them now, and I just want to talk about the differences before I actually do them. Here's the second problem. I want to work through 2 square root of y over 5 square root of r. So once again, we have a radical in the denominator. And looking at this second expression, I don't really care about the radical in the numerator. That's fine. But I cannot leave the radical in the denominator. And the third problem I'm going to work is square root of t minus 4 over square root of t plus 5. Now let's compare these 3 problems, and then we're going to work them out. You notice the first one, we simply have a radical in the denominator. The second one, we have a radical in the denominator, but also multiplied by a number. So these are both factors in the denominator. The third one, we have a radical in the denominator, but I also have another term. Once again, remember, terms are things you add together. I have 2 terms here. To get rid of the square root of x for the first expression, and to get rid of the square root of r for the second expression, we're going to do the same thing, and we will do it in just a minute. However, the method we use for these first 2 expressions will not work for the third one. The third one, we have to use a different method, and I will show you that when we get to it. So, for these first 2 cases, whenever you have a radical, and in this case, just let me make a note, all the problems I'm going to do here and the problems in this class are all going to be just square roots. You could theoretically have cube roots or 4th roots in the denominator. And to get rid of those radicals is a little more complicated, and it's beyond the scope of this class, so we're not going to go over those. So notice also we have all square roots. So when you have a square root of x, in this case 5 square root of r, notice these square roots in the denominator are factors, as opposed to this third one where we have 2 terms and the square root of t is just one of the terms. Whenever your square root is a factor, rationalizing is very simple. And let me just do the first one. You simply multiply the top and the bottom of the fraction by the radical. So I'm going to multiply this initial fraction by square root of x over square root of x. The reason we can do this is because anytime you have something divided by the same thing, that equals 1. So we're not really changing the value of 2 over square root of x. It's just going to look different. And now the whole key to why this method works, the numerator, I can just write 2 square root of x, but the denominator, square root of x times square root of x, just to make it sort of more obvious, is really square root of x squared, right? That's what it means to square something, to multiply it by itself twice. And now here's an important rule you need to learn. Anytime you square a square root, it's almost like the exponent of 2 and the square root cancel out, and you're simply left with what's under the radical. And so that's how we get rid of the radical out of the denominator. That's called rationalizing the denominator. Now let's look at the second example. It was 2 square root of y over 5 square root of r. Now once again, the only thing I'm really worried about is the square root of r. I don't care about the square root of y in the numerator, and I really don't even care about this 5. That 5 in the denominator is fine, that's not a problem. It's really the square root of r. So what do I do here? I multiply the top and the bottom by the square root of r. Now for the numerator, whenever you multiply two radicals with the same root, since these are both square roots, we can just write them all under one radical, under one square root. Now if I look in the denominator, here's my 5 and square root of r times the square root of r. When you square a square root, you end up with just what's under the radical. Now let's look at the third example. Square root of t minus 4 over square root of t plus 5. Now the problem here is, once again, I've got a square root in the denominator. But now it's not a factor, in a sense it's a term. It's almost like I have a binomial in the denominator. Someone could try to multiply the top and the bottom by the square root of t, but when you do that, you would see that you end up with a square root of t still in the denominator. So you haven't solved the problem. Here's a little trick that we can use to get rid of this square root. And let me just show it to you, and then I'll give you the name of it. I'm going to write the exact same two terms, square root of t and 5, but what I'm going to do is I'm going to use the opposite sign in the middle. Here, they're being added together, so therefore I'm going to subtract. And of course, I have to do that both to the, whoops, that's a t, sorry, should be a t, minus 5. Now what happens here is, I'm not going to take the time to do this multiplication. Well, first of all, let me tell you, these are called conjugates. Conjugates are when you have two binomials with the same two terms, but just the opposite sign in the middle. One is going to be addition, and one will be subtraction. So in a sense, when we have this situation, what we do is we say we multiply by the conjugate. Now, what happens is, when you multiply two conjugates, there's a little shortcut. Now, you could FOIL these, and you would get the correct answer, but there's a little shortcut that I prefer to use, and this shortcut is the same every time. You simply take the first term, and of course the first term is the same for both parentheses. You take the first term and you square it, and then you always put a subtract in the middle, and then you take the second term and you square it. So that's like a shortcut to multiply conjugates. You square the first term, subtract, square the second term. Now in the numerator, I'm going to have to actually go, and what I'm going to do is, I'm actually, just for this problem, I'm not going to multiply this out. There's really no need to. So let me just show these being multiplied together. So, final answer. The numerator, I'll just leave in that form. The denominator, what happens when you square the square root of t? You end up with t minus 5 squared is 25. And there you go. Now there could be, in some problems, you might have to multiply out this numerator because possibly once you do that you could factor and then something might cancel out. But in this case, nothing is going to be gained by multiplying out the denominator. So those are the times when you have to rationalize the denominator, which basically means we have a radical in the denominator and we have to get rid of it.